question. A beam of gas molecule is incident normally on a plate AB. Each gas molecule has mass m and velocity v. The incident beam falls on area on the plate and all the molecules strike the plate elastically. This is a plate. Number of molecules in unit volume of beam is n. I think there's a one data which will take help of. Is n. Number of molecules per unit volume. So when the plate is moved towards right, the force required is F1, external force. And when plate is moved towards left, the external force needed is F2. We have to get the difference of these two forces, F2 minus F1. Okay, let's first the molecule here will come and collide elastically. Let it rebound with it, or let it after collision, let velocity be V1. Applying quotient of restitution formula, U V1, U minus V1 by V minus U. So, and since elastic collision equal to 1, solving will get the velocity of molecule after impact. Then change in momentum of molecule or ball, what will be that? Change in momentum of molecule. That should be equal to delta P1 M V1 minus V. So this will be M into V1 value will substitute here. So I'll get the change in momentum. The magnitude of that will take it. So next, number of molecules striking the wall per second. N number of molecules per unit volume is there. So how many will strike per second? That should be equal to like a number of molecules per unit volume into volume by time. But here the molecule and the wall, if we were at rest, okay, we would have just ended up the same number of molecules will strike it. Since the molecule and wall, there's a relative motion, so the dx will become relative separation per unit time into area will become into n will become number of molecules striking the wall per second, this quantity. Now this I got now number of molecules striking the wall per second. This is the change in momentum of each molecule. The product of these two will get the net force, because how you define momentum, rate of change of how you define force, rate of change of momentum. Similarly, when the wall is moved towards left, let the molecule rebound with a speed v2, not rebound, or we'll just assume v2 here. Then applying the convention towards right positive, E equal to v2 minus of u, the wall moving towards left, I'm taking negative, minus of u minus of v, E equal to 1. Since E equal to 1, solving will get the velocity of molecule after impact equal to this much. Change in momentum of molecule. Change in momentum of molecule. So again, the similar final momentum minus initial momentum. Solving this will end up this one. Okay, again here number of molecules striking. Now in this case, the molecule and wall are moving opposite. So therefore V plus U will come. So how to calculate now? These are number of molecules striking per second. These are number of change in momentum of molecule in the second situation. So therefore the product of those two will become the force exerted by the moving molecules on the wall. That is what F2. The difference of this is what we have to take this one. You have to calculate. Okay. Yeah. Well. We'll end up the class. I have another class. Okay, I'll end up. We'll meet again tomorrow. I'll come waves and sound, some good questions I'll bring. Okay, till then, bye. See you. Take care.